When you picture the age of dinosaurs, um, those incredible horned giants like Triceratops, with their massive frills and those iconic horns, they probably spring right to mind, don't they?
Oh, absolutely. They're just so, well, iconic. They really dominate our imagination at that time.
Exactly. But what if we journeyed like way, way back, before those titans were even around?
Yeah, let's hit pause on the spectacular headgear for a moment and travel to the early Cretaceous, north central China specifically.
Okay.
Today we're diving into the story of well, a smaller, earlier relative that's, I think, every bit as fascinating, Archaeoceratops.
Archaeoceratops, right. The name itself sort of hints at something ancient, doesn't it? So
Yeah.
for this deep dive, what are we really trying to, uncover about this ancient horned face?
Well, the goal is really to get the essence of Archaeoceratops. Where did it fit in the big story of dinosaur evolution? What was its environment like?
And what its features tell us.
Exactly. What do its characteristics reveal about the early development of horned dinosaurs? We'll be looking at the scientific classifications, the findings detailed in paleontological papers.
Okay, the core science stuff.
Right.
Yeah.
To piece together the picture for you. And importantly, we'll try to steer clear of getting bogged down in, super technical jargon.
Sounds good. So this ancient horned face name, it's pretty evocative. What's the story there, and where exactly did this dino actually live?
Yeah, Archaeoceratops literally means ancient horned face. It's very descriptive for an early member of the ceratopsia group that's the horned-faced dinosaurs.
Right.
Its discovery firmly places it in the early Cretaceous period, specifically the Aptian stage, so quite a long time ago.
And the fossil evidence comes from north central China?
North Central China. Okay, got it. Can we zoom in a bit more, like, geographically?
Yeah,
Where exactly did they find these fossils?
we can. Both known specimens were found in what's called the middle gray unit of the Shenminbo group. That's within the Gongpukwan Basin.
Which is part of the Maison-Shan area in Gansu province. So, yeah, very specific geological layers in that part of China.
Wow, that's incredibly precise. You can almost like picture the paleontologists working right there. And who were they? Who actually unearthed this ancient creature?
The first species, Archaeoceratops oshimai, that was named by Dong Jiming and Azuma back in 1997.
Okay, 97.
And what's really interesting is that this was the very first basal ceratopsian found in that area.
The first one, basal neoceratopsian. Break that down a bit.
Sure. Basal here basically means it's kind of near the root of this branch of the dinosaur family tree.
Okay, an early version.
Exactly. An earlier version before things branched out into the later, more specialized forms like, Triceratops. And Neoceratopsian refers to a specific subgroup within the bigger horned face dinosaur group.
Got it. The very first of its kind in that prehistoric neighborhood. Must have been a huge find for understanding dinosaur evolution there.
Oh, definitely.
Eh.
A landmark discovery for the region.
And was A. oshimai the only Archaeoceratops they ever found? Or were there others?
Well, not quite.
Yeah.
Later on, actually in 2010, another species was identified. It was named Archaeoceratops eugingsiensis.
Ah, okay.
So now we actually have two distinct species in the Archaeoceratops genus.
2 for the price of 1 ancient face. All right, so we've got the when, the where, the who. But what did this thing actually look like? My first thought is like a tiny Triceratops. Is that right?
Huh. That's a really natural first thought. But Archaeoceratops was actually quite different in scale. It was pretty small,
How small?
reaching maybe about 0.9 meters, so
Yeah.
roughly 3 feet in length.
Yeah.
And weight-wise, maybe around 10 kilograms. That's about 22 pounds.
Whoa, okay. So closer to like a medium, maybe large dog size. Not a rhino at all.
Exactly, not a rhino. So yeah, definitely need to recalibrate that mental image.
Totally recalibrating. What other physical features really set it apart?
Well, a key difference from its later, more famous relatives is that Archaeoceratops was primarily bipedal.
It walked on 2 legs.
Mostly, yeah. Walked on 2 legs.
It did have a comparatively large head, though. That's a feature it kind of shares with the later ceratopsians.
Okay.
And maybe that large head, even without, big horns or frills, was important for other things, like maybe housing bigger jaw muscles for chewing tough plants.
That makes sense. So
Yeah.
big head, small body, 2 legs, still feels pretty different from a Triceratops.
Yeah.
Now, about that horn face part of the name, did it actually have horns?
Okay, here's where it gets really interesting, and maybe a little confusing given the name.
Uh-huh.
Despite being called ancient hornface, Archaeoceratops didn't have those prominent, well-developed horns we see later.
No horns at all.
No real horns. It only had a small, bony frill projecting from the back of its head. Just a little ridge, really.
Wow. Okay. So the name's a bit misleading then, or maybe forward-looking.
Kind of. And this absence is really striking because it suggests that, whatever advantage this group had early on, it wasn't necessarily about massive head displays or defense.
It might have been something else entirely,
Hmm.
like maybe improved bite force or better attachments for those jaw muscles we mentioned. The frill and later the horns might have evolved for totally different reasons down the line.
A frill, but no horns. That's a huge difference. And a big clue about where it sits evolutionarily. You mentioned two specimens of the first species, A. oshimi. Were they, like, complete skeletons?
The first one found, the holotype that's kind of the main reference specimen, IVPP V111114, was partially complete.
Okay.
It had the skull, some vertebrae, the pelvis, and most of one hind foot.
And the second one?
The second one, the paratype, IVPP V1115, was also incomplete, but gave different clues. It had a really well-preserved tail, parts of a hind limb, and a complete foot. Interestingly, it was slightly smaller than the holotype.
Ah.
And yeah, identifying these specific specimens, holotype and paratype, it's really crucial in paleontology. They basically define the species for everyone else studying it later.
So piecing together these, like, puzzle pieces gave paleontologists a pretty solid idea of its overall shape and structure.
Exactly. You build the picture from the fragments you have.
Now, you mentioned earlier it's a basal neoceratopsian. Let's circle back to that. What does that classification really tell us about its spot in the dinosaur family tree?
Right. So Archaeoceratops belongs to the ceratopsia. As we
Right.
said, that means horned face in Greek. It's the big group covering all those herbivores with the parrot-like beaks.
Okay, the whole group.
Yeah. Within that big group, Archaeoceratops is classified as a basal neoceratopsian.
Basal meaning early.
Foundational.
Sort of like foundational, yeah. Using that tree analogy again, think of the big Ceratopsia family tree. Archaeoceratops sits closer to the main trunk. It represents an earlier version, that's the basal part, before the branches leading to the later, more specialized Neoceratopsian forms like Triceratops really took off and developed.
Okay, so it's like an early evolutionary starting point for the fancier horn-faced dinos that came later.
Precisely.
And I think you said they actually set up a whole new family just to classify it. That's right. Yeah, back in '97, when Dong and Izuna formally described it, they created the family Archaeoceratops just for it.
Wow.
They recognized it had this unique mix of sort of primitive features and some more advanced ones. And since then, other dinosaurs like Heliosaurops and maybe Yamaceratops have been suggested as potential members too.
So it wasn't totally alone.
Probably not. It suggests Archaeoceratops wasn't necessarily some, completely isolated early experiment, but maybe part of an early radiation of these kinds of dinosaurs.
So Archaeoceratops wasn't a lone ancient horn face, but maybe had some close early relatives. Why is understanding this specific dinosaur so important? What key insights does it really give us?
What's really significant about Archaeoceratops, I think, is that it gives us this crucial window, a snapshot into the very first stages of ceratopsian evolution.
Before the big horns and frills.
Exactly, predating the development of those iconic, prominent horns and the large, often really elaborate frills we see in the later giants like Triceratops and Styracosaurus.
Mhm.
It shows us an earlier body plan. It gives us clues about the first evolutionary steps within what became a very, very successful group of plant-eating dinosaurs. It helps us understand, what features were there right at the start and which ones evolved later on.
It's like seeing the initial sketch for a masterpiece, maybe, before all the final details and colors were added.
That's a great analogy, yeah.
So we have a clearer picture of what it looked like, where it fits. What about its diet? I mean, horned face sounds like it could handle some serious plants, even without the actual horns yet.
Absolutely. Archaeoceratops, like all ceratopsians,
Yeah.
was definitely a herbivore, a plant eater.
Okay.
Now, if we think about the environment back then, the early Cretaceous, it's really important to remember that flowering plants, the ones that dominate many ecosystems today, they were still pretty limited, geographically restricted, not widespread yet.
Ah, right. Different menu.
Totally different menu. So the buffet options for Archaeoceratops were quite different from what, say, a Triceratops would have munched on millions of years later.
So no big fields of flowers or grassy plains for this little guy.
Probably not. It's far more likely its diet was mostly the dominant plants of that time. Things like ferns, cycads, and conifers.
Tougher stuff. More fibrous.
Yeah, imagine tougher, maybe more woody or fibrous vegetation compared to lots of modern plants.
So how did it manage that kind of roughage, especially without the massive jaws and those grinding tooth batteries you see in later ceratopsians?
Good question. It would have relied heavily on its sharp, parrot-like beak.
Ah, the beak.
Yes, the beak was key. It would use that to snip off the leaves or the fronds or maybe pine needles. Then it would use its teeth, which, yeah, were simpler than later ones, but still adapted to sort of grind and chop up the plant matter before swallowing. That specialized beak was a really important early innovation for tackling that kind of tough plant food.
Okay, all right. Let's try and wrap this up then. Our deep dive into the ancient horned face Archaeoceratops. What have we learned?
Well, we've seen it's a relatively small bipedal dinosaur from the early Cretaceous of China,
Right, an early relative of the famous horned dinosaurs.
but crucially, lacking those prominent horns. It just had that modest little frill.
And its diet was likely ferns, cycads, conifers. The tough stuff of the time, processed with that sharp beak.
That sums it up nicely. It really highlights its importance as like an early stepping stone in the evolution of this really amazing and diverse group of dinosaurs.
It really does spark the imagination, doesn't it? Thinking about Archaeoceratops, its particular features, small size, walking on two legs, that little frill, and the world it lived in. It makes you wonder what pressures, what selective forces might have eventually pushed its descendants towards developing those huge horns and massive frills later on.
Hmm.
What story does this ancient horned face, this early version, tell us about the future success and diversification of its entire lineage? Definitely some fascinating food for thought there.